For number 14 of sample final part 2, we have a cyclist is riding a bicycle whose wheels have a radius of 10 inches. Suppose the wheel turn at 290 revolutions per minute. Find the following. So let's capture what we do know. Let's capture that the radius is 10 inches. And that it revolves at 290 revolutions per minute. And anytime we have revolutions per minute or rotating or going around, that's always going to represent angular velocity. And we use the Greek letter omega for angular velocity. Looks like a W, but it's Greek letter omega. And they ask us in our first question is find the angular speed of the wheel in radians per minute. So we already have the angular speed. That's what omega is, but we just don't have it in the right units. We want it in radians per minute, and we have it in revolutions per minute. So we're going to convert that 290 revolutions per minute by using the fact that we know that one revolution is equal to 2 pi radians. And usually we'll not express radians as a unit, so we'll just say one revolution is 2 pi because it's understood to be radians. So I can write that equation two different ways. I could write it as one revolution over 2 pi, or I could write it as 2 pi over one revolution. So I'm going to pick the second case. And you say, well, wait a moment, why did you pick the second case? Well, by picking the second case, this is what happens. So I'm going to circle that one. By choosing that variation, when I write that here, what's going to happen is that 2 pi over one revolution, the revolutions are going to cancel. So that one revolution in the denominator will cancel with the revolution in the numerator. So that's why I knew to pick the second, is because I wanted to cancel revolutions in the numerator to make sure I had revolutions in the denominator to do that. And you say, well, how did you know you wanted to cancel revolution? Because I wanted it in radians per minute, not in revolutions per minute. So now I have the right units. I have 290 times 2 pi radians per minute. I'll go out to the Alex calculator and evaluate that expression. They tell me in this example to round to the nearest whole number. So let's do that real quick. So we went out to that calculator and got 1822.123 ... And when we round to the nearest whole number, we got 1822 radians per minute. Part B asks us to find the speed of the cyclist in miles per hour. So when they ask for the speed of the cyclist, they're asking for the linear velocity v. And v is equal to r times omega. And we know that the radius of our cycle was 10 inches. And then we also know that the revolution in radians per minute was given by 290 times 2 pi radians per minute if you express it with exact values. And so we just need to make sure that our units are correct. We want our units to be in miles per hour, and we have it in inches per minute. So what I'm going to do is I'm going to convert those inches to feet, and we'll just do that in a little thought cloud. So I'll just make my little thought cloud kind of red up here. And I'm just going to use the relationship between inches and feet. And I know that 12 inches is equal to 1 foot. So I can either do 12 inches is 1 foot, Or I can do 1 foot is 12 inches. Now I want to cancel the inches. And if I look at the inches, I notice that the inches are written in the numerator. And so since the only thing in the denominator is minutes, then what I want to make sure is I want to use the ratio that has inches in the denominator to cancel with inches in the numerator. So I'm going to multiply by 1 foot over 12 inches. And that will cancel the inches. But again, I'm asked to find it in miles per hour. So I know that miles is equal to the following ratio. I know that 5,280 feet is equal to 1 mile. So since I want miles in the numerator, because I want miles per hour, I want to use the ratio where the mile will be in the numerator. So I'm going to do 1 mile per 5,280 feet. Also, you'll see that the feet in the numerator will cancel with the feet in the denominator. So that's the second reason why I want to use the miles per feet. All right, so I'll go ahead and cancel my feet. And I'm almost on the home stretch, except for, again, we want miles per hour, and I have miles per minute. So I'm going to use another ratio that relates hours and minutes. And I know that 60 minutes is equal to 1 hour. So I'm going to express my ratio such that I can cancel the minutes in the denominator. And in order to do that, I need to have minutes in the numerator. So I'm going to write 60 minutes in the numerator and the 1 hour in the denominator. So I'll have the following when I simplify. Give myself a little more real estate. So I have 10 times 290 times 2 pi all over. I could write the radians, but really it's unitless, so I don't really need to write the radians. So I'll just go ahead and erase it. And in the denominator, then I have miles in the numerator. And then in the denominator, I have 12 and 5,280. So there's the 12 and there's the 5,280 and then feet. No. The feet canceled. Sorry. I have minutes. Minutes, Mom. I got minutes. So I got miles per minute. So I'm going to multiply by 60 minutes and 1 hour. That way my minutes will cancel. Woohoo! And I've got my right ratio, my right units, miles per hour. So I have 10 times 290 times 2 pi times 60, all divided by 12 times 5,280. Now I know that 12 goes into 60. You don't have to do this, but I'm going to cancel the 12 goes into 60 5 times. And then I could cancel one of the zeros into that, so that will make it a little bit nicer as well. So then I'll have 290 times 2 pi times 5, which will give me 10 pi, all over 528. A little bit less to type into the calculator, and that's in miles per hour. So let's go ahead and get that computation, or get the value of that expression. On the Alex calculator, we got 17.254 miles per hour. And when you round that to the nearest whole number, you're going to get 17 miles per hour.